Okay, so let me start with good news for you. Actually, two good news. First, I can do this talk within 30 minutes, so there will be a lot of time for questions or another cup of coffee, up to you. And second good thing is that you need to remember only 3 things after this talk. Really easy stuff, basics. But as a wise man said, sometimes the easiest things are the hardest to understand, correctly and holistically. By the way, my name is Andrzej. I'm working for a fully remote company with totally flat structure from Poland, which is Software Mill. And today we're going to talk about Gatling. But please be patient, because we need to start with some theory. Theory about performance tests. And to be precise, I want to show you why it is so hard to check performance of your application system, why it is such a pain in the 3 letters or 4. And this will be only a tip of an iceberg, and I will cover benchmarking of whole web systems, not some micro benchmarking of some part of the code, which is basically totally different story. Okay, so first of all good performance tests should simulate as close as possible the production environment. In terms of hardware, so the same CPU, RAM, storage. Usually production machines are quite powerful. Powerful means costly. So there is a good chance that you will not be able to buy a copy of production environment just for performance tests. On the other hand, you might face the paradox that your test environment is faster than production. Simply because you are using, for example, SSD drives, and on production you are forced to use some old, expensive network attached storage, which latency is just horrible. Anyone experienced this kind of situation? Okay, so it's only me, the lucky one. The same software, so operation system, virtualization, databases, etc. And sometimes this could be hard to achieve because of some crazy licensing policy. For example, you cannot update some software version because of backward compatibility issues, etc. Load. So how to simulate real daily application production load? Obviously, if you want to test Facebook-like application, you will not launch billions of users. You need some clever way to simulate this. Usually, you are in the 99th percentile of application with some reasonable number of users. And even then, you don't have to launch exactly the same number of users to get some knowledge about performance of your application. Another key attribute is isolation. Definitely, you don't want any interference, like now, with your performance tests. So if you are forced to use... So if you... Okay. So if you are forced to use the same environment as QA testers, then I feel sorry for you. Just remember to check if nobody is running some heavy cron jobs. Even without this, it will be really hard to analyze the results. Anyone experience this kind? Okay, one person, probably more, but you are too shy. Yeah, try to automate things so that you can run your tests during the night when nobody is using the environment. And basically the same story everywhere. To overcome most of these problems, you need money. And if this is a blocker for you, just look for some optimal compromise. Or change your strategy completely and run performance tests on production. Yeah, I strongly don't recommend this approach, but who knows? Maybe you're lucky enough, and in your case, it won't be such a bad idea. Just remember to delete test data when you're done. Okay, so beside dedicated infrastructure, you will need monitoring, very good detailed monitoring of your hosts, application, databases, messages, bus, network. Basically, all parties must be connected to the monitoring. And then logging. A lot of logging, but I would say intelligent logging. So things like database queries response times, or your HTTP endpoints response times, correlation ID, especially in case of microservice architecture, some remote access to the logger configuration so that you can change logging level dynamically without restarting the app. So things like that. And you need those two things because one of the aims of performance tests is to find potential bottlenecks. And without data, you're just a person with an opinion. That's it, believe me. And usually I'm dedicating this slide to my former technical leader because he pasted this guy so many times on our Slack channel that I could wake up in the middle of the night and I see this guy's face. Really. I even start to using this sentence in my personal life. Let's say during some difficult conversations with my wife. Yeah, I'm not so sure if that was the best idea. Who would predict that she will use it against me? And not all my ideas and beliefs are based on some strong data. Anyway, this is the first thing I want you to remember after this talk. And usually when you are a senior developer, you're starting to feel something inside of you which I would call performance intuition. And someone is asking you for help, and look, we have a problem with performance, and you are just saying, oh, it's definitely database, fix there. Oh, it's definitely message bus, fix there. Or it's network, fix here. No, this is completely wrong. Usually, after such tip, the performance will be the same. And in worst case, it will be worse. The algorithm is pretty simple. First, collect the data. So monitoring, logging, profiling, etc. Find the bottleneck, but based on the data. Fix the bottleneck, but fix only one thing at a time. Not all possible bottlenecks, not all imaginary bottlenecks, one thing. Then collect the data again and check your assumption. Is it better? Is it worse? How much is it better? So things like that. And go to step number 1. And even if you are aware of this, the temptation to skip step number 1 or even step number 4 is so intensive that you will do it. Sooner or later you will do it. It's like fighting with an addiction. You need to train your strong will and always make your optimization based on some data. And if you are interested more why it is so hard to fight with your intuition or how your brain is working under the hood, I could recommend a great book written by Daniel Kahneman, Thinking Fast and Slow. And there you will get answers for questions like that. So, really recommend. Okay, another problem is math. So, how to measure the results? And here you need to be super careful because there is an old saying, lies, damn lies, and statistics. And believe me, it is so true that it will hurt you so many times. And of course, this is the second thing to remember. Maybe not only this one sentence, but the whole slide. So let's say we have a chart with response times like on the slide. And clearly there is something wrong with the last response. So if you use arithmetic mean, basically arithmetic mean is useless. It's not possible to spot a problem with the last response. If you use median, even more useless. Standard deviation, also useless. Standard deviation is okay only for normal distribution, where in case of IT system, normal distribution is not so common. Actually, I would say it's quite rare to have it. So another example of statistic nature could be Anscombe's quartet, which determines 4 different data sets with nearly identical simple statistical properties, yet appeared completely differently when represented as a graph. So imagine that those are your performance characteristics. The numbers are the same, but the graphs are completely different. So the question is, what should we use then? And my answer is percentiles. In my opinion, this is the best metrics to get the overall view of performance characteristic of your application. But be careful again, I'm not sure if you can see this, and check percentiles implementation, because they could use mean and standard deviation, which of course makes them useless as well. Another example could be drop wizard metrics. Who is using drop wizard? Nobody? That's good, because you will need to remove it in other ways. So in case of drop wizard, the library collects some set of samples, and from this set of samples it will randomly choose some subset, and based on that subset it will generate percentiles and other statistical properties. So even if you have exactly the same results each time, you could get different statistical properties, which for me is crazy because it's not possible to, for example, compare results. The next question could be, so which percentile should I be worried about? Number 90, 95, who will vote for 90? Come on, people. 95th. One person. 99. One person? 99.9. Depends. So no, actually the answer in this for this question is all of them. Why? Because there is something called coordinated emission problem. And this is the third and last thing to remember after this talk. So yeah, 10 minutes and I'm almost done. Of course I'm joking, stay a little bit longer. So what is this coordinated emission problem? It was first introduced by Gatling. By the way, this guy is my performance guru. I recommend to watch his video presentations. He really knows things, trust me. And I will try to explain this problem using very simple example. Let's say we have a test scenario for 60 seconds, and each second we start one request and wait for the response. And the responses are pretty fast, so after 1 second we will get our response, or 1 millisecond, it doesn't matter, it's just a matter of scale. But after 31st request, we will brutally kill the application. So system exit 0, kill -9 to simulate very long GC pause or some problems under application heavy load. So in this case, we will not get the response for 31st request. But most of the tools will assume, since there is another 30 seconds to the end of the test, so most test tools will assume that 31st request took 30 seconds and ended with some error. So let's check percentiles for such example. We have 31 samples and percentile 70, number 70 is 1, 90, 1, 95th, 1, 99, 12. Okay, so we see performance degradation since 99th percentile. But there is something smelly here. 95th percentile is 1. Our application was dead for almost half of the test, and 95th percentile is 1. This is something is wrong here. So let's check how these numbers will look like in case of 10,001 sample. In this case, percentiles number 99, 1, 99.9, very close to 1. So this is really wrong, right? Maybe percentiles are not such a great metrics after all. In this case, the problem is with testing methodology and usually testing tool. So let's check those numbers in a real life scenario. In real life, we will not wait for a response to the request 31st. We will just start another request after 1 second, 32, 33, etc. And this way, we have half of the samples when the application was perfectly healthy and half of the samples when the application was dead. And now the numbers are completely different. Percentiles 50 is okay, 70, 90, 95th, 99th, and we can see performance degradation since percentile, basically 70th. So those are real percentiles without coordinated emission problem. And the previous one have this problem. Any questions to that part? Could be in Polish. No? Sorry, once again? Okay, so I suppose these graphs show pretty well why this problem is so important. This orange line is your SLA contract. If you are able to deliver application with performance histogram under this line, you will get a lot of money, a lot. And you check your performance, you are pretty happy with the results, the red line. But unfortunately for you, your customer also checked the performance using different tools, different methodology. Of course, the blue line. And the blue line is the real percentiles. So you can say goodbye to your big money contract. Fortunately, you can validate your results and check if you have this problem using very simple calculations. You just need to collect total time, maximum request time, and for example, you want to validate 99th percentile. Then you need to calculate percentage of time for maximum request, which is 50%, so 30 divided by 60, you know it, 50%. Then expected time for 99th percentile will be at least 50% minus 1%, so 49% of total time. And 49% of total time is 29.4. So if those numbers are different, then you have coordination emission problem. And usually the difference is really, really huge. Now the difference is, okay, it's something, but usually it's thousands times different. So any questions? Okay, basically this is percentile 100. So if percentile 100 takes 50% of total time, then 99 percentile will take 50% minus 1. You can also observe the graph. Usually real percentiles will grow with this nice blue curve, where in case of fake percentiles with coordinated emission problem, you should observe this peak near the 99 something percentile. Okay, because this presentation will be about Gatling, I should warn you that this tool is not fully resistant to this effect. Actually, I know only one tool resistant to this effect. But if you use it correctly, you can minimize this effect to some reasonable level. And I will show you how. And the last problem with performance tests are tests themselves, in the sense that someone needs to write them, support them, and usually you have deadlines for features, not for tests. Sometimes it is not so obvious what should I test in case of performance tests. Obviously not all corner cases, not all functionalities. I would say you should choose most business viable paths. So in case of e-commerce system, you probably would like to check how many users can buy something in case of Black Friday in parallel, or how fast is your search engine functionality. So things like that. Finally, it's time to for Gatling. By the way, I really like good names for Encode and for tools as well. And Gatling, in this case, is a very good name. If you close your eyes, you can almost feel like this guy. Of course, you will shoot with requests, not with bullets. Okay, why Gatling? It's based on non-blocking asynchronous stack, so Scala Accaneti. Each virtual user interaction is represented as a separate actor, and thanks to this you can generate huge load even from your local machine. On the other hand, for example in JMeter, the only reasonable open source alternative to Gatling, each virtual user is represented as a separate thread. And to be honest, you can generate pretty decent load using JMeter as well, but it will cost you more RAM and more CPU. You can use Scala for your performance tests. How cool is that? No more JMeter XMLs. Don't get me wrong, I was using this tool for a long time, and at the end I quite like it. Yeah, the UI is horrible, but I'm using Linux, so I don't care. But the worst thing are those XML files. Good luck with versioning it, review it, etc. And here you can use normal programming language. Maybe in case of Scala, normal is not the best word, but still you can reuse it, refactor it, versioning it, etc., etc., etc. By the way, who is using Scala here? Okay. Who is using Java? Who wants to use Scala? So this is a great way to introduce Scala to your organization, because usually performance tests, you can create separate repo. You don't have to mess with business code, so remember about this tip. You can use Gatling even if you are a total Scala noob like me, because it's DSL, it's so easy to read, to create, etc. I hope that you will find it later. Yes, there is an recorder so that you can generate some tests based on the traffic from the browser, but please don't use it. Of course, you will use it anyway. So just remember that this is generated code, and at some point you must refactor it. Math is good. Very nice visual reports out of the box. And you can use Gatling for not only for performance tests, but also for integration tests. And actually, it's quite important because usually I'm creating integration tests at the beginning of the project. And transition from integration tests to performance tests in case of Gatling is really, really easy. And here's your first Gatling scenario. I'm not sure if you can see it, but you need to extend Gatling simulation class. Then there is some set configuration part, and then the essence. So scenario code and launching code. And you know how to make it nicer. So for example, you can start with creating your own My Simulation class and hide all the configuration there so that you can see the most important things. And as you can see, Gatling DSL idea is to provide one big fluent builder, and tests should be readable almost as normal sentences. So scenario, execute, HTTP, get root, pause 7 seconds, etc. And you just need 2 imports to make it happen. So core and HTTP. Any questions? Good. A little more complex scenario. It looks okay. It's quite readable, but once again, very simple techniques like method extractions, and you will get much nicer code. You can go further with that and divide complex scenario to a smaller one and then combine them together. And I hope that this is so obvious that you are thinking, oh my God, Captain Obvious, give me a break. And yet, I want to explicitly highlight this because so many people forget about this, and then test code looks like one big spaghetti mess with copy-paste pattern implemented everywhere. Yeah, by the way, remember to put good names for your request. At the end of the test, you will get something like this on console, and if there is a problem with some of the actions, you will know exactly which action is problematic. So naming request 1, request 2, it's not the best idea. Use more domain names. More on DSL. So you can, each response should be somehow validated. You can check the status like on the slide. You can check the payload using regular expression. Basically, you can check everything in the payload using regular expression, maybe except binary payload. But I encourage you to use built-in support for parsing JSONs, XMLs, even CSS selectors in case of HTML response. I don't want to go into details here, it looks a little bit fuzzy, but everything is in documentation. What is worth to say here is that you can save some part of the response to the virtual user session and use it later by Gatling expression language, so this $sign with curly brackets. And this is especially useful in case of complex business scenario when you need to transfer some data between requests. So loops, you can use loops so that you don't have to repeat the same code over and over again. Here is a basic repeat loop. There is also for each, during, as long as, forever. There is something called polling, very similar to loop, but in this case, your scenario can move forward and polling will be executed in, let's say, scenario background. Conditions, so classic if else, switch, random switch, etc. Once again, useful in case of complex business scenario, but similar to production code, too many ifs, too many conditions is not the best idea. So keep your tests rather easy and straightforward. Try max, very useful functionality. Let's say you want to send money from Alice to Bob, but communication between them is asynchronous, for example, via Kafka. So if you send the request to check if money was sent, was received, right after sending money, this check could fail, simply because message from Kafka was not consumed yet, but it will be eventually. So this check will pass probably after a few retries. And instead of try max, you could put pause here, but pauses in case of performance tests is not the best idea because you want to put maximum pressure on the system under test. And if you have pauses in your test scenario, then it will be really, really hard. So try max is definitely a better idea. And this brings us to the scenario setup where you can define things like how many users should be started at once, or how many users should be started using some ramp over time, or maximum duration of the tests. About starting user over time, there is really a lot of possibilities. Here you can see very, very basic example. And this is a reminder for me. So to avoid coordinate emission problem, if you have business scenario, don't use loops. For example, you have some scenario and you want to repeat it 1,000 times. So instead of loops, run it for 1,000 users. And this way you will limit, maybe not eliminate, but limit the coordinate emission problem. So pretty important. You can specify, maybe do you have some questions to that part? Okay. You can specify global assertions for all requests. For example, you want to check if response time was less than 50 milliseconds for all the tests, or that failed request percentage is equal to 0. About failed request percentage equals 0 in performance tests, it's not always the best idea, simply because in case of heavy application load, you should expect some timeouts. So I would say some percentage is okay. Maybe 2, maybe 5, maybe 0. It's highly dependent on the application. Throttling, very interesting feature, although I never use it. In this case, your scenario will reach 100 requests per second within 30-second ramp, hold it for 1 minute, jumps to 50 requests per second, and hold it for 2 hours. And this is especially useful in case of soak test, where you want to determine if system can sustain continuous expected load. And soak tests are very, very long performance tests. To provide some unique or random data for your virtual users, you will need feeders. And feeder is just a simple key value map, which keys could be accessed by Gatling expression language. And you can create feeders manually, like on the slide, or use some built-in support for parsing JSON, CSV files, JDBC, Redis, sitemap, etc. And feeders are very useful because, for example, you want to test your search engine. If you search for 1,000 times the same company, after the first request, you will probably fill all possible caches, and all other requests will basically check your cache's infrastructure, nothing more. And this, using feeders, you will generate company name each time different one, so you actually checking your search engine. Yeah, I said that configuration part is quite boring, maybe except one setting, which could be useful in case of legacy systems, or maybe I should say old-fashioned, where there is no so many JavaScript frameworks on front, and you want to simulate real user experience. So not only downloading the HTML code, but also all the resources like images, CSS files, scripts, etc. And you can a little bit simulate the browser behavior by these settings, but in my opinion, the Gatling was not designed for this kind of test. But anyway, you can try it. So launching Gatling, very easy. If you are familiar with SBT console, so one command for launching all the tests and one command for launching a single one. And there is more. But the purpose of this presentation is not showing all aspects of Gatling. So just remember that you can create custom validators. In case of HTTP, there is support for SSL. You can simulate server-sent event. There is a basic cookies support. You can use Gatling for testing WebSockets. And trust me, I tried many different tools for testing WebSocket, and each time it was a nightmare. Where in case of Gatling, the support is pretty okay. It's not so great like in case of HTTP communication, but still you can successfully use Gatling for testing WebSockets. You can use Gatling for testing JMS systems. Actually, the whole architecture is quite pluginable, so you can use community plugins for testing Cassandra, Kafka, RabbitMQ, etc. Recently, my colleague created a plugin for testing zero message queue, and this is actually great because it shows that the project is not dead and the community is quite active. Okay, now I'd like to share very quickly my personal experience with Gatling. So before you start debugging Gatling and waste a lot of time like me, because for sure there is a bug in Gatling, not in your beautiful test code, just remember to turn on logging. And you can log all request responses or just a failed one. And the second option is definitely better for very, very long performance tests. And trust me, you will save a lot of time thanks to logging. Reports, so this is so nice that I need to show you. So beside information like on the slide, which you will get on your console, you will get very nice visual reports with all necessary performance indicators, so percentiles, min, max, median, standard deviation, etc. And very nice graphs like response time distribution, response time percentiles over time, number of requests per second, etc. And this is generated for all actions. But for example, you can choose the longest action in 95th percentile will be search for, obviously. And now you will get all the details only for this one action for free. Questions? Okay, know everything. Two days later. Okay, so as I said, using Gatling, you can generate huge load even from a single machine. But nowadays, your application is probably deployed on a bunch of nodes, some crazy cluster system, cloud, or whatever. So for testing such system, one machine, it won't be enough. So instead of this, what you really want is to have something like this. And you can achieve it manually. So you can just start a few nodes, then upload the test code to this node, start the test, collect the results, and generate reports based on that results. And it sounds like a waste of time, because it is. You can use existing services that will do it for you. Just select, I want 4 nodes, launch it, that's it. And of course, those services are not for free, but I suppose your time is pretty expensive as well. So put more focus on tests themselves, not on how to launch them. And actually, that was the last idea I want to share with you. So if you have any questions whatsoever, now it's the good time for it. No?
Could you show one more time the slide when you were validating the percentiles? I didn't want to take it with me.
If you need the slides, it's not a problem. I can send you the slide.
Yeah, this one. Thanks.
Yep.
So from the Gatling client, if you say this is my task and then you wait for a response, it takes X amount of time. But what if along the way there is a microservice that talks to a microservice that talks to a microservice? Can these guys somehow all coordinate and give you the answer as to who took the piece?
It's a different tool for this kind of problems. Here you have just endpoint and you don't know what is behind this endpoint. So if you want to check your microservice architecture, you would probably want to use something called Zipkin, where you have spans and you know each microservice time, etc. Yep.
Gatling with some tools which could you track your performance application performance during the time.
Could you be more precise?
Integrate Gatling with some tools which could you show you the performance your application during long time period.
Okay, so as I said, you can achieve this manually because each time you can generate this visual reports, and this is simple HTML code so that Jenkins could copy this to some locations and you could have all history. But also those tools, so Gatling Frontline and Fluid.io, will provide you the whole history of your launches. So
Okay, I integrated with Jenkins plugin, and it shows the graph, for example, mean response time during time. I thought you could mention some other tools like that. Do you know?
So maybe you could tell me which tool you want to integrate with.
Okay, for example, Jenkins has plugin which could draw a graph for each scenario and represent it time of the mean response times during the time. Yes. This is an example.
Okay, definitely your Jenkins could generate the report and you don't have to do anything more. Just copy it to some place and that's it. So probably yes.
Is it possible and is it a good practice to run performance test not periodically but continuously? So I can simulate my daily traffic, for example.
Yeah, for sure, but to be honest, I never do this in a periodical, systematic way. So it's always like, okay, we need to test the performance and 2 weeks of testing performance. Yeah, I know it's bad, but it's pretty expensive to check performance in case of resources and peoples, etc.
And is it possible to create more complex scenarios, for example, including daily and nightly traffic?
Yeah, you mean that, for example, during the night you have low traffic?
For example.
It's just a matter of launching users over time. So you can put some configuration and launch, for example, one test with 10,000 users and second test with 1,000 users, and it will be just a matter of one settings.
But is it possible for single test which will be run for a whole day, for example, with different user distributions?
Yeah, yeah.
So if I understood it correctly, this test stack is expensive, so you don't have the like your continuous integration pipeline. You just run them like before release or something.
Yeah, I shouldn't say that. Right now, no. No, unfortunately, no.
Run them like before release or something.
Yeah.
And
And not all release. Usually the big one.
so, but have you heard about like integration with continuous integration, like having this test in pipeline?
Yeah, for sure, it's the way to go to run the performance tests each time. But right now we have more, how to say it, other topics are more important. So it's life.
From your experience, which use case is most common? So you launch the performance test only once to check something because you suspect that there might be something wrong, or continuously, let's say, night by night, to just verify that the performance can decrease or something?
Well, actually, it's up to you. For sure, before the version 1.0, you should test the performance, and then you need to incrementally check it at some point. But it's really hard to say one universal law for all possible application types. So you need to decide this.
From an experience, you run them day after the day. How reputable you have the results or server response time? So, for example, I will put this into continuous integration and run it every night. And I put some data on the graph just to measure how performance change during the development every day. So, would this be valid or there is quite big delta between the day?
Yeah, the delta. Usually the data is up to 10%, and if this is minus 10%, then everybody is happy. If this is plus 10%, okay, let's run it again. And then usually you have plus 5%, so the less value. But when it is more than 20%, I think you should check what is going on. Usually I'm checking the slowest actions, and because problems usually are from them, so yeah, something like that. So I would say more than 20% in delta should warn you.
What is the biggest problem to include it, the test into your pipeline, because you already wrote the test and you have it? What is the problem here?
Actually, it's not a problem. It's just a matter of money, because you need to start some nodes for tests. For example, 4 nodes just for Gatling, and then you need to start whole infrastructure. So in my case, it's 16 servers, which is quite problematic and costly. And I cannot test production. So yeah, launching the whole infrastructure usually takes about 30 minutes with tests. After hour and a half, usually I get some results if there is no problems. So
Production seems to be a good idea in terms of monitoring, and you have real traffic, so you can monitor and
yeah, definitely production, monitoring and production is something that must be done, and must be done really, really good.
releases, you do your performance. So it's locally made or on production, or you have a
No, it's just a copy of production environment. Because we have a good DevOps guy and infrastructure as a code, blah, blah, blah. And really starting the whole infrastructure from zero is just a matter of script, one script, which launch a lot of more smaller scripts. Anyway, it's quite easy to set up it, but it's, as I said, costly.
Are you familiar with any tool, maybe some plugin to Gatling for generating test cases or play real traffic in production where you get access logs or something else just to get?
Not really. You can, as I said, there is a recorder. You can create a proxy and record browser traffic, but it's not the same. Yeah, but usually you have some path that you really need to check, most business valuable paths, so not all possible user interaction. And actually this is a good way to have few important paths and you don't have to check every possible use case. Okay, no more question, right? Thank you very much.